In today's video, we're going to look at polygons. Okay, so this is the next chapter when it comes to two-dimensional plane figures. And what polygons are they are shapes that have a number of sides. Okay, now generally we think of polygons that they start when you get to pentagons, so 5 sides, but because we have a triangle with 3 sides and we have a square with 4 sides, but actually triangles and squares are also polygons. Okay, now the reason that they're split up like this is because a square, rectangle, and a triangle are used for lots of other things. Okay, and they're used kind of as tools as well. Okay, whereas these polygons, when we go on to the pentagon and the hexagon and the octagon, they are kind of more just things in themselves. Okay, so what we have with us here is that in polygons, what we're going to try to learn is to identify the different types of polygon shapes, to recognize polygon shapes around us, and to construct various polygons of various methods. Now, basically, a polygon is a two-dimensional shape, so that you draw on a sheet of paper, and made up of straight lines. Okay, so that's our kind of main thing. We have two types of polygons. We have irregular polygons, where all of the sides are different, or one or more of the sides are different to the rest of them. And you have regular polygons where all the sides and all the angles are equal. Okay, so we'd normally be working with regular polygons with triangles, squares, hexagons, pentagons, and octagons and things like that. Okay, so we generally work with regular ones. And when it comes to constructions, regular pentagons are the ones that we'd be looking at, because due to the fact that irregular polygons are irregular, the same constructions don't always work on those. Okay, so what we have with it then is, if we go down a bit more, regular polygons. What we have in this is we have a few things that are the same no matter what shape that we're looking at. Okay, now in this one they have a pentagon, but this would be true for the other types of polygons as well. Okay, we have the different names. Okay, so we have the apex, which is the point that's in the top. Okay, and every polygon would have an apex. Some polygons might have two apex depending on what way it's orientated. We have a vertex, which is an angle, so one of the points. So the apex is the apex, but it is also a vertex, because a vertex is every one of the corners. Okay, you have your interior angle and your exterior angle. Okay, so interior being inside the polygon, exterior being outside the polygon. Okay, you have the radial angle, which is if you join two vertices into the center, you will always end up with a triangle if you're looking at a polygon. Okay, and you will have your radial angle on the inside here, and then a radial line is just a line that joins it up. Okay, and then you have the number of sides. Okay, so they're the main things when it comes to what the different terminology is and the different names, and you need to know what the names of these are. Okay, because you could be given information and be given it with these names. Okay, so we need to know that construction. And down here in the keywords, it gives a little bit more detail into it as well if you want to know what it is. Just one important thing from this is that the internal and external angles of a polygon always add up to 180 degrees. Okay, because it's always a straight line coming out from one side to give us where the exterior angle is. The interior angle is fairly straightforward, but the exterior one is gotten by extending out one of the sides and getting your exterior angle. Another example of that, just if we weren't to take the one on the ground, if I was to draw this one and to keep going up, then my exterior angle for up here would be there. Okay, and then we would have the interior one in there. And because it's a regular polygon, this angle here would be the same as that angle there. Okay, because it's regular. So if we go on then to the next page, what we have, just to have a quick look at this, is we have the different polygons. Now, what you're going to see here, and what's very interesting about this, is that the more sides a polygon has, the closer it gets to looking like a circle. Okay, the reason for that is just because you'll see as the sides go on, it just becomes more round. But what you have is you have your triangle, your square, your pentagon, your hexagon. Heptagon we're not going to use very often. we have an octagon, which we're going to use quite a bit, and then we have our nonagon, decagon, and we have a circle. Now, the circle is an interesting one because you might say there's no straight edges in a circle, okay? But if you look at this, if we zoom in on this a little bit, as the polygons, say, get more like a circle, if you were to keep adding numbers of sides, so that's with 10, so if you were to put 100 sides on a polygon, it would start looking very like a circle. Okay, and basically what a circle is that it's a polygon with an infinite number of sides. Okay, so that there's an infinite number of sides in that circle, which makes it into a circle. So a circle is also a polygon. Okay, when it comes to this. Going on then to how to actually construct these. Okay, now what we have with it is, this is really important up here at the top. Okay, we have a few different polygons here. And what's important is the angles that are in this, okay? So what we have, and the relationship between these angles. So first of all, the most important thing to remember with a polygon, if you remember this, then you'll be pretty much able to draw whatever you want, is that the exterior angle of a polygon is 360 divided by the number of sides, okay? So they all add up, all of the sides add up to 360. So if you divide it by the number of sides, because they all have to be equal, because it's a regular polygon, then you will get the exterior angle, okay? From that as well, an easier way of thinking about this is, instead of saying the central or radial angle equals 360 degrees divided by the number of sides as well, the easier way to think about this is that the central or the radial angle in here is always the same as the exterior angle, okay? So 120 with our triangle there, or 72 with our pentagon, 60 with our hexagon, and 45 with our octagon, okay? So an easier way of thinking about that is just to remember that the radial angle is, or the central angle, is a little bit easier to remember if you say central angle, is the same as the exterior angle, okay? And then the interior angle is 180 minus your exterior angle. Okay, so what we have with that then is, you're not really expected, and I wouldn't expect you to remember, that a triangle is 120, a pentagon is 72, 60 degrees for the hexagon, you might remember that one, and 45 for the octagon. The easier way to learn this when it comes to kind of remembering how it works and then transferring that to actual exams is to just remember the fact that the exterior angle is 360 divided by the number of sides, okay? And then it doesn't matter how many sides you're given. If you use that calculation, then you'll always be able to just figure it out in the exam when you get it, okay? So you'll see here, 360 divided by 3 is 120, 360 divided by 5 is 72, 360 divided by 6 is 60, and 360 divided by 8 is 45, okay? So as long as you remember that calculation there, it doesn't actually, you don't need to remember the 120, 72, 60, and 45, okay, when it comes to that. But it is very important to remember that calculation. So if we move on then to actually drawing a polygon here, and the first one we're going to look at is a regular hexagon. What we have with this is that it is quite simple. We are going to start off by drawing the base. Okay, so the first thing you'll do is draw the base. Now, in this case, we're just normally going to draw the base just horizontally across, okay? And given whatever length of side that you're given. What you'll then do is you'll say, right, I have my base, I now need to figure out my angle. So you'll see here that the second thing here is to work out the exterior angle, okay? And because the exterior angle here is 60 degrees, we can use the 60 degree set square, okay, to draw in the two sides here. So with your 60 degree set square, you can just come up and you can draw in your side over here. Now you don't know what length it is for the moment, and you can draw your side in over here, okay? Now the length of those don't matter for now, they're just going to be light lines, okay? Now the next thing that you do once you've done that, so line across the bottom, then up at your 60 degrees and up at your 60 degrees. Doesn't matter the length of their construction. Then we're going to come over to this one here. Now this one is the most important one of these steps, okay? And the reason for that, so this step here is the one that we really want to make sure we remember. The reason for that is because we're going to use a compass here to move our distances, to take the length of our distances, because it's more accurate, okay? This way of doing it is the most accurate way of drawing a polygon, Okay, so what we're going to do is once you have your the length of your side here, so we have our 80 down here at the bottom already. What we're going to do is we're going to take that on our compass, so from one point to the other, and swing it up onto the side. And what that will do is that it will make absolutely certain that the length of the side is what we're looking for. Okay, so if we take that distance and we swing it up and we get the point here, and then we swing it up and we get the point here. That way, if we were to make any mistake with this side, so if at the beginning we were to, instead of making that 80, if we were by mistake, if we made that 79, what would happen then is if I made it if this was 79 and then I actually got it right for this one and I made it 80, and I got it right for this one and I made it 80, what would happen is you'd have real big inaccuracies when you got to the end, because the most important thing with a polygon is that all the sides are the same and the angles are equal. So if you don't have the sides the same, then you're going to kind of run into problems when it comes to drawing it. So that's why we want to make sure we use our compass. Okay, we also want to be very accurate in that this should be 80, but we want to use our compass. So we're much better off if we draw this and we made a mistake in the first one. We're much better off making the second one here 79. Whoops. Second one here is 79. Then we would be to make that 80. Okay, in terms of actually drawing the shape. So what we get then is we get the 6 and the 3 here, so we get those two sides. We can then use our set square again to draw up the sides from those, okay, and keep the distance with your compass. So these two distances here, so this one and this one, are also drawn in with my compass, okay, making sure we don't change what it is, so making sure that they are the same length as the bottom one here, okay. And if you've done all this with your compass, you now have all of these sides are equal. And then what you have then is with this type of polygon, with a hexagon, you basically have a way of correcting your own work, because what should happen at the top here is that the top line from 5 here, as they have in the book, to number 4 should be horizontal. Okay. Now the reason for that, so this should be that should be horizontal. The reason for that is because the top point, or the top line of a hexagon, should be parallel to the bottom. Okay, so these two here should be both horizontal. So we have the bottom here, there and there. They should be parallel to each other. So you know, if that you use your t-squared to draw the line from 5 to 4, if it isn't horizontal, then you've made a mistake, most likely with your compass or with your protractor. So remember what I've said to you before with your protractor, and that your protractor can be inaccurate, and that's why with this one we use our set square instead. So if you did this with your protractor, that's more of a chance of you making a mistake. So because this is 60 degrees, we use our set square to cut out that reason for having a mistake. So with this one, your most likely thing is that you might have made a mistake when you were bringing your distances. Okay, so just be very careful when you're bringing your distances around, and you end up then with your hexagon. Okay, so they're the steps. You start off, draw the base, draw up your 60 degrees because we worked it out, and then put your distances onto the two points. Then come back up again with your 60 degrees again, put your distances on with your compass, and then your 5 and your 4, your top line should be horizontal if everything else has gone right. And as I say, it's basically like correcting your own work. You'll know if you've done it properly that will be a horizontal line.